Hi, everyone. Hello. So you know how when you're flying and you're like in zone D or whatever in the back of the plane, and you're feeling like move already when you want to get out. That is how I feel. So there is a door over there which seems underused for next time. So no, wait. Okay, anyway. Okay, all right. So welcome. So this is not quite week 3 because we didn't have a lecture on Monday. So we're going to finish up what we haven't done last week, a few slides, and then we're going to do a practice quiz, which is on Quarkus currently. It's a practice quiz. It's not graded. It's just to give you an idea of what it's going to look like. So we're going to talk about it when we get to it. No pressure. It's not graded. It's available on Quirkus. You can do it now if you want. And then we're going to do an introduction to Boolean algebra. I'll explain what that is in due time. So where we stopped last time, sorry, quiet down, please. So where we stopped last time is print versus return. So this is where we stopped, right? So again, return means the same thing as equals in algebra, right? It's a part of the syntax. It's saying this function computes the value high in the same way that the function might compute like a plus b or something. It happens that it always returns the same thing. That does not by itself print anything, right? So if here you say compute high, that's the same as saying square root of 2 as opposed to print square root of 2. You don't say print, it's not gonna print. Okay? Here, we're saying print, and then we have compute high. So what is compute high? Well, the string high over here gets substituted in. Does that make sense? So this prints, this does not print. So here's an interesting situation. This print high, as opposed to compute high, is a function that has a job. It has a side effect. The side effect is to print the string high to the screen. On the other hand, it doesn't compute anything. So it looks like it might, but it doesn't, right? It's an instruction. It doesn't say return anything. So when you say print high over here, you're supposed to print the value that print high returns, but print high does not return any value. So for that reason, what happens? So if you call just this, high gets printed. Here, what happens is you call print high. As a result of that, high gets printed to the screen. So while you're trying to compute print high, as a side effect, high is output to the screen. But then also, you're giving the instruction to Python, print this thing over here. What's this thing? Well, it's nothing. Print high didn't compute anything. So Python has a special value for whatever gets returned if nothing is returned, which is none. So the effect is going to be high is printed and then none is printed. So let's look at what that looks like. So I'm just like doing the same thing as the slides, right? So here I'm saying print high, and then over here I'm going to say print high, and I'm going to say print high like so. So I'll put the breakpoint over here. Let me save it. I'll create a folder. So that might look different on your computer. That's kind of the operating system is doing this dialog box. So this is W3. And I'll save this like so. So I didn't have to save it, but just to be nice. So if I run this, what happens is high gets printed, then high gets printed as a result of this call, and then the value of the thing that's highlighted over here is none, so none got printed. So this is why here you had the output high and none. So let's trace it. So I put a breakpoint on line 5. So click here. I run it. So now I'm about to execute print high. So what that means is I'm about to go here. So print high does not take any parameters. So this is why this is just open paren, close paren. And now I'm going to be on this line over here. So I'll step in like so. So I'm about to say print high. So that means that over here, high is about to appear on the screen. And indeed, It has. And now I'm about to say print high. So print is a function. In order to compute print, or have whatever it is, in fact, I first need to compute what print high is. So it's going to go into print high again. So if I say step in, like so, I'm again in print high, and I'm doing print high line by line. So that means that high is about to get printed again. So over here, high is going to get printed. It got printed. And now I'm going to go back. And so as you might remember, in ISO, you want to press continue in order to not open up a new file on the last line. So I'll just press continue. But what's going to happen is the value of this is going to be none. So none is about to be printed at the end here. So I'll press continue again. And none got printed. Okay. So none is a special kind of value in Python. You can have, so you can say none, you can say A is equal to none. And then if you print A, it's going to be none, stuff like that. Okay, so that's just like a special thing in Python. All right? Yes.
None and zero was like.
No, well, so there are, so we'll get into something like this later on. They are not equal. They're not the same. But none can get converted. Sometimes none gets converted to false. That is.
I understand none is an empty set.
No, it's not. None is its own thing. None is just none. Okay. All right. Yes.
If you did print polynomial argument, would it give you none? So,
Say it.
like if you call on the print function, but you didn't put print high as an argument.
Yeah, so that is what I had done. So I mean, I have to say print something, right? Or like if it's nothing, then it would print, just go to the next line.
So, but if you do print high, because it doesn't return anything, it'll just say none, because there was no return.
Well, no. So think about, so the question was kind of when not would none be printed. And the answer is, if a function doesn't return anything, then by default, the return value gets set to none. Okay, so maybe this will make it clear. So if I say like result is equal to print high, and then I say print result. So let me comment this out. So what would happen? So here high gets printed. And the reason high gets printed is that we are executing this function. So we get to this line. And then res gets set to none. And that's because we're saying whatever this is, which happens to be none, put it in res. And then we print res. So this is none. And maybe what you were asking is, would high be printed here? Well, no, because res is just none.
What I'm saying is, like, if you didn't put res, if you put nothing, no argument, would it just be blank? Like, what would print nothing?
So like print nothing, like so. So you can do it. That would print literally nothing, right? So none is its own thing. It's not nothing. It's not the empty set. None is just none. Yes. Yes, you can. And in fact, well, you would not usually do it. The question was, can you do return print high? And the answer is sure. In fact, we had an example just like that over here. So what does print return? Well, actually the same as print high, print returns none. So if here you say return print high, that still returns none because print returns none. Okay. All right, so we're getting a little bit too into the weeds here. It's important to know, like, if it happens a lot that you would print something and it turns out to be none because you forgot to return or something. So it's important to be aware of it. You wouldn't use it intentionally, right? So a lot of what I'm saying here is useful if you make a mistake, as opposed to if you're actually planning to do something useful. Okay. All right. Other questions? All right. So that is that. So just one more example. So here we have a function that does kind of what you asked about, but in a more elaborate way. Well, no, actually, no. So what did, sorry, I was mistaken. So what does this function do? So it has the effect of printing hello to the screen. And then also the value that it actually returns is high. So the effect of this line is to just print hello. So the value of this is high, but I didn't say print it. So the effect of this is just to print hello. The effect of this is you call this, so you get to print hello, so hello gets printed, and then the value of this entire thing is gonna be high. So you print hello because you get to this line, and then you print high because the value of this is high. Make sense? All right. Let's do one more. So this is the same function. And here we're saying result is compute high print hello. So the effect of this, the side effect is to print hello. And then the value of this is high, and high is put into res. So when we say print res, what gets printed is high. Make sense? So I want to just give like general advice and stuff, and then do an example. So what we've seen there is like there are rules to how every line runs, right? And all the rules are in the slides. So eventually what you hope to do if you choose to kind of, do a lot of programming is you'd be able to kind of look at the code, do a vibe check, and see, kind of get a feel for what it's gonna do. If you're just starting out, that is just not gonna work. Like you can try it, but you'd be wrong a lot of the time. So when reading what you wanna do is, what does this line do? What are the rules that apply? Let's kind of list them out. It's always unambiguous. Like the thing about code is that it's the same every time because it follows the rules. Like there is exceptions that you'll see in 190, but for now, it's going to be the same every time. Actually, can anyone think of an exception that we saw this semester? A line of code that doesn't do the same thing every time. Anyone? Yeah. Okay. Yes.
Function calculator?
That is the same every time. Yeah.
The rounding was quite fun.
No, that's all deterministic. Yes.
Random function in that.
We haven't seen it, but yeah, but that is true, but we haven't seen it. Yes.
See.
No, that's actually the same every time. Yes. Say again? Yes, that is what I was looking for. So so it's a weird fact in physics that time only moves in one, well, if you import it, then time only moves in one direction. So if you choose to concentrate on physics, you'll see that there's like deep questions about how that came about. But this function, in fact, you call it more every time, and you get a larger number every time because there's more and more seconds since January 1st, 1970. Very sad if you think about it. Yes.
How does the Python program knows if the computer is not connected to the internet?
The computer has a clock. So the clock gets synced using the internet on modern computers, but every computer has a clock.
What if the clock is
If the clock is, the question was, what if the clock is broken? And the answer is exactly the same thing happens when the computer clock is broken as when any other clock is broken. So like if your microwave is like not having the right time, doesn't have the right time set, which usually it doesn't, and it just doesn't. So
So in that case, it will always print the same number.
No. So like there's no way I think for a computer to be running at all and for the clock. So it's like, like there's like current through quartz. If there is current, it's pulsating. It's fine. So, yeah. All right. So in fact, like in hardware, you'll see that kind of the clock is really central to the operation of a computer because kind of every time it ticks, it executes another instruction. So if it's not ticking, it's not executing anything, so nothing's happening. So that means it's frozen at the very least, or probably it's not. Yeah, other questions? Okay, I'll teach you how to set the clock on the microwave some other time. Okay. If you think about it, like a pretty key skill for an engineer, like, okay. So that's how it is. So I want to do a little example of how that works. So this is the file from the course website. So if I run it right now, it's going to give an error, and that's because there is a typo. So, and also there is like an issue here. Okay, so let's debug it. So this is, again, it doesn't do anything in particular. It's just like meant to be funny and interesting. So what's going on here? So here we're saying make concrete, and then we're saying of name, and here there is an error. So the errors are sometimes a little bit difficult to read. They're sometimes using difficult terminology. So what you want to do is like just like here do the vibe check, right? So it says take 0 positional arguments. So something to do with arguments and how many of them there are. So that hopefully suggests to you, okay, like there's like 1 argument here, what's going on? At this point, hopefully you see, okay, like what's going on is here, we sent the name in, but we didn't remember to write name here. Make sense? So I'll write it like this, and I'll run it. So usually when I'm debugging or when I'm reading code, I just run it at least until it runs without errors. So if there is red, I just keep going. Yes?
So say got rid of the name, like
you could make it global if that's what you're asking, but
like you know how like we're entering a parameter in the print function. If we get rid of the name there and we get rid of the name in the main concrete function, would it still?
Yeah. There's multiple ways. Yeah. Okay. All right. So let's run it. See what happens. So here again, another error. So it says name. This is not defined. So whenever it says name is not defined, so we saw this kind of thing before, right? So if you say like ASDF or whatever is equal to 5, and then you do something like this and you mean ASDF, what you'll get is name is not defined. So some of the time it means you just made a typo. Some of the time you forgot to pass, like you forgot to define a parameter or something. So usually I just look and say, okay, so this looks like maybe it's a typo. Right? So, and here I'll hopefully kind of look it up. So one trick in Paizo is if you highlight this, then you'll see all the other instances of make destruct. And here I don't see this. So if I fix it, and then I highlight it again, then make destruct would also be highlighted. Make sense? So I'm never going to ask you for like details of like how would you do this or that in Paizo, but I'm going to demonstrate it during lecture. So, okay, so let's try to run it again. So Control E, Command E on a Mac. Okay, it's printed. So what I want to do now is just go through it and see what's going on, try to predict what's going to happen ahead of time. So I'm putting a breakpoint on line 15. And here I'm saying name equals Newton. So what I expect is that the value of name is going to become Newton. So I'm going to say next, and I'm going to check. So name is Newton. So far, so good. So here I have the function make concrete, and I'm saying print the return value of make concrete. So in Paizo, I can just check what the value is going to be ahead of time by highlighting, saying Alt Enter, or just copying to the shell over there. I can also just logically think about what's going on. So does make concrete return anything concrete? No. Right? It just says name equals Newton love Civ, which is not true, which is why this function has no effect. Okay. So Civ might like Newton. Doesn't have to be mutual. So that means that make concrete name is going to be none. And that's what gets printed. So what is name going to be? So remember, parameters are a type of local variable. So if I change the value of a local variable inside a function, that does not have an effect outside the function. So when I print name, it's going to be just plain Newton over here. Make sense? Okay. What about make abstract? So we're sending name over here. So name we can check is Newton. We're sending it over here. And what we're going to return is name, which is Newton, plus loves praxis. So the value of this is going to be Newton loves praxis. And then we're saying print whatever is the value, which is Newton loves praxis. So that's what's going to happen. What is name? Name is still Newton. Just like here, we didn't actually change any values. We just said compute name plus law of praxis in the same way that you might compute 5 plus 7. That does not change the value of 5. So if we print the name again, it is Newton. What about make destruct? Well, again, does not return anything. So it's going to print none, but it has a job. It has a side effect. The side effect is to set the value of the global variable, to set the value of name to Leibniz. Right? So that means that this is going to print none. And then the value of name has now changed. It is now Leibniz. I'll press continue so that a new file does not open. All right, questions about this? Yeah.
So, because we have our regular global variable in the main part of the code, and then we go Newton, right? When we go to the function definition, make destruct, and then we say global name, is that the same global variable or different?
So when I say, the answer is it's the same. So when I say global name, what I mean is that when I'm referring to name, I mean the global variable name. And there, yes. Otherwise, it would be the local, you said. Yes. So, sorry. So, like, no hypothetical questions because I want to move on. After lecture, I'm happy to answer. Sorry. So, any questions? Not hypotheticals. Yes. Okay, that is extremely not hypothetical. However, you have a typo in your code that I cannot fix from here. Sorry. So, after lecture. Okay, all right. Yeah, sorry about that. It's just that, like, often, like, if I don't have an error but you do, that's the thing about code. It's consistent. It's always the same unless you ask for the time or for a random number. So if we have different results, it's because either I messed up or you messed up. So, okay. All right. So, what about writing? We had this discussion in the lab session on Thursday evening. So I just wanted to repeat it. So when you have a job, say, okay, like what is the input going to be? If you're writing a function, what's the input of the function? What are the outputs and effects that I'm intending or that I'm asked for? I strongly suggest like write down examples, like for this specific input, what is the output going to be? Just write it down. And then one thing that I very often see in the lab is people try to write a whole bunch of code and hope that it works. That, sometimes, like I still remember it was on PY a very long time ago. I sat down and I like wrote some like complicated algorithm for 2 hours and then I compiled and it worked the first time. But that's not the usual situation, okay? So what you want to do is you want to write the smallest possible piece of code, test it right away, augment it a little bit, test again, and so on. Yeah, I think it's worth saying now, as I don't think there is a way to really internalize this lesson until you experience not following this advice several times, but I told you so. Okay. All right. What I want to do is, if there is time to do the practice quiz today, we will do that. But if there is not, we will practice the quiz on Wednesday. It is available to you now. You can practice it now. But I want to cover Boolean algebra a little bit. So there might or might not be a practice quiz. It's right now on Quarkus. It's a practice quiz. It's not graded. Do it whenever you like. I also give you time to do it. So, okay. Boolean values. So we've already seen them. Hey, this is interesting. Forget the practice quiz. Who cares? Okay, I'll move the box so you can see George Boole's face better. So we've already seen the Boolean values. So those are special values in Python. They're true or false. Right? And in the same way that like 1 + 3 is equal to 4 and 4 is a value and you can type 4 into Python, you can type in true and you can type it false, but also you can have expressions that equal true or false. So for example, 5 is greater than 3, the value of that expression is true. Okay, so if I type in 5 is greater than 3 in the same way that if I say 5 + 3, I'll get 8. If I say 5 greater than 3, I get true. It's the same kind of thing. Okay? Oops. So 41 = 40 just means nothing because it means like take 40 and put it into 40. You cannot put anything into 40. So 40 = 40 would be true if the left-hand side equals to the right-hand side, would be false otherwise. So something like 20 is greater than 40 is false. So 7 greater or equal than 7 is an interesting situation. That is true because it's true that the left-hand side over here is greater or equal to the right-hand side. Specifically, it's equal. Does that make sense? So something like this is false. So not equal in Python is written as exclamation point equal sign. So 41 is not equal to 5. So that's why that's true. On the other hand, 41 is not equal to 41 is false. Because if you think about it, they're equal. Okay. So Boolean algebra, like why did this guy get something named after him? So he invented Boolean algebra. So the idea is you can write compound expressions that involve Boolean values that have Boolean values the same way that arithmetic expressions have values that are numbers. So, for example, something like 40 equals to 40 and 5 is greater than 4, that is true because 40 equals to 40 is true and 5 is greater than 4 is also true. Something like this is false because although 40 is equal to 40, 4 is not actually greater than 5. You can also have not, so we'll do each one of those in turn. So not means inverted. So 4 greater than 5 is false, but not false is true. So let's do an example with not. So the value of not true is false. The value of not false is true. So here is a little program. Oops, sorry, that's the wrong one. So we're saying, so this is just part of the comment. So we're saying if not praxis equals love, print hi, else print hello. Okay. So does praxis equal to love? Anyone? Well, in some sense, but the string praxis and the string love are two separate things. Okay. So that means that this is false. So not this is true, which means that you'll go in here and you will print hi. Questions about this? Yes.
This sort of like order of operations where it tests the Boolean first and then it puts the not in front of this.
So it's not exactly in the order of operations because there's oh, you mean like the parentheses? Yeah, that would be clearer. Yes.
But you don't.
Yeah, it's better to. Yeah, I mean this was fine, but yeah, you're right that this is better. Yeah.
So it's why you if not instead of doing praxis and exclamation mark equals close.
Yeah, I mean, yes, the reason is I wanted this example because it's funny. Oh, no, exclamation. Sorry, I thought you meant exclamation equal sign. No, in Python, you cannot do exclamation. Like that doesn't work. That would just be syntax error. So like it's just not. Like, so exclamation point did not work that way in Python. So it does in like Java and C and stuff, but not in Python. Yeah.
In the numerical values, you have to say if it's true or not before you run the program?
No, so what's happening here, right, is we're saying compute this expression. So this expression, it has an equals, right? So we're comparing this and this. And they're two different things. They're not equal, which is why the value of this expression is false.
Okay, so it's always false if it's not the same string?
Yes.
Okay.
Well, it's always false if the left-hand side is not equal to the right-hand side, right? So it's the same as saying something like 5 is equal to 6. No, it's not. So that's false. But you can also, so I kind of like try to introduce it in a kind of logically rigorous way. But really you would read it the way you would read it in English, right? So if it's not the case that they're equal, then do this, otherwise do that. Does that make sense? Yeah.
Say you have a Boolean variable. Let's just say it's
Sorry, no hypotheticals. Okay. Sorry, I'm banning hypothetical questions. After the lecture, I'm happy to answer anything. Okay, so all right, so and. So this is how and works. So it's useful. Sorry, quiet down, please. So it's useful to first think about it like this, right? So I want to say, like, if it's both the case that 5 is greater than 3 and 4 is equal to 5, then print high. If not, then don't. Right? So that's what this expression means. And what we're doing here is we're just like elaborating like this intuition of what does and mean. So what and means is that both A and B are true. So the only way for the expression to be true is if A is true and also if B is true. Okay, so that's kind of like, I think it looks like a lot, but really and is extremely intuitive. Oh, you're saying if A and B means if A is true and also B is true. So in this case, it will not print because 5 is greater than 3, that is true, but 4 is not equal to 5, so that is false. So you can think about it, and Python thinks about it like algebraically, that you can think about it intuitively as well. Yes, non-hypothetical questions, anyone? Yes. Yes, you can, but you and it works, but it will give you problems with or, so don't do it, just use parentheses. And also, that was semi-hypothetical, like can you have would be like and sorry. Okay. That good question though. Okay, all right. So or is a little bit different from English. So I can say if 5 is greater than 3 or 4 is equal to 5, then print high, and it will print high. And this example is intuitive. This is saying if this or that, then print. If neither, then don't. So technically, A or B means either A is true or B is true or both are true. And this is what this is saying here. So if there is a true anywhere, so if there is a true here or there is a true here or both are true, then the entire thing is true. So if you put it in an if expression like here, then that would evaluate to true if something there is true. Okay. So this is a little bit different from, so do we have time for fun? Yes. Okay, so let's just, so this is meant to be fun. So you can have like various things. So I can say like X is equal to true, and then so not X would be false, right? So I think some people know where I'm going with this. So I'm not having any functions, but I'll do the main block. So if you highlight and press tab, it will indent everything. So I'm pressing tab, both are indented. If you want to unindent, you can press shift tab. Okay, so all right, so I don't want to print this. So I'm saying X is equal to true. So X is now true. I can query X. X is true. So if I want to print not X, that would be false. So X is true. So I can also say something like, like not X. So you can do parentheses, but you can also do this. So this would be true, right? Because not X is false, and then not false is true. And you can in fact say not X, and that would be false again. And that would be because the value of this expression is true, and not true is false. Okay, that's enough fun. So why do I always press the wrong button? So one thing to understand, and we will not have the time for the exercise. So or the technical term, which I will not test you on, is that the or in Python is inclusive. So in English, I can say something like, for dessert, I will have ice cream or pie. And you might interpret it as me saying I'll have one or the other, but probably not both. In Python, or does mean one or the other or both. So in English, it's a little bit ambiguous. So you could say that the English or, you could imagine other human languages where it's not like that. But the English or is what's called exclusive, or arguably at least exclusive, which means that I mean one or the other, but not both. The Python or is one or the other or both. Again, written out here. So true or true is true. Okay, questions about this? All right, so there's let's do this exercise. Let's say that we want to write something that's going to be true if pie or ice cream in the English sense is true. So I'll give you a couple minutes. So this will be the last thing. The practice quiz is online now, but we'll do it on Wednesday, and I'll do the examples on Wednesday. But let's take 2 minutes to think about this. So there is an expression that you can write there, which will make it work. And this was covered in lecture. There's no extra stuff. So if you're stuck, don't try to write it out. Like try to make it so that the output is right. Maybe don't write the exact expression if you can't come up with that. We're still thinking. Okay. I think that's not very many people, so presumably some people gave up. Who thinks they know how to answer this? All right. Guy in the very back.
So you could start a if I equals
Yeah, that is one way to do it. Yeah. Does anyone have a shorter way of doing it? Yeah.
Pie or ice cream is double equal to true.
Pie or, well, no, that would not work because that's the same as saying pie or ice cream, and that's the inclusive or. Yes. Yes, that is what I was looking for. Yes. Yeah, good job. So it's kind of a funny fact is that if you write it out like this, that does the job exactly, right? Because like, what does it mean? It means that like pie is different from ice cream. So one of them is true and one of them is false. And that's what we want, right? Yes.
That's why it's a reason why you did that extra side.
What?
Generally, if you're comparing two things, so you have to do like the two equal sides.
Well, I mean, here I'm saying not equal rather than equal. So the exclamation point comes together with the equal signs, right? It's not like a separate thing. Yeah. All right, okay, yeah, great job. We'll do the elaborate version on Wednesday. And there's gonna be practice with both globals and locals and this in the lab. See ya. Bye, thank you.